Hello, this is Mr. Burkhart. This is going to be a video for 3C, possibly 3D on the workbook, but I wasn't really happy with how well I explained that last page on 3B. Like I just told you what the answers were, but I didn't really feel like I did a very good job of explaining why it was happening the way it was. You may have noticed, and I really feel like probably what we might want to ask an expert. And so I found this video on, this is AP Classroom, as you can see up there. It's video 3.6. So I think at this point I've asked you all to be on AP Classroom. You don't have to sign up to take the test. I think it's actually too late for that, but please sign up for AP Classroom so you have access to the resources there. If you need help because you haven't done it yet, reach out to me. You should be able to find this daily video. I can't find a different way of sharing this video with you. Like I wish I could download it or find it on YouTube or something. That'd be better for me, but it's not. It's just here at AP Classroom, they're territorial. Watch, if you didn't understand why the answers were the way they were on 3, so long story short, watch this video for a deeper understanding of why the answers were the way they were on 3B if it's concerning you. All right, let's move on to 3B then. So, 3C. Here we have a dump truck is making a very fast left turn as shown in the back are 2 blocks of ice, one of mass big M and one of mass little m. Big M is bigger than little m. The truck does not roll over. Well, that's good. Sketch the paths that the left and right mirrors take during the turn. All right, so the left and right mirrors are, so here's the left mirror and here's the right mirror, and the paths that the mirrors are going to take during the turn are something like this, right? Like that. That's supposed to, yeah. And using 2 different colors, sketch the paths the blocks of ice take during the turn. And so the blocks of ice, since they're slickery, the big block is going to go like this and slide up. It's not going to slide, it's not going to slide out of the truck, but it's going to slide on the back of the truck. They're both going to slide like that. All right, your friend who is not in physics class, lucky duck, says the blocks go to the outside of the truck because a centrifugal force is acting on them. In a few brief sentences, explain why your friend is incorrect. The reason the blocks appear to go to the outside is that they were moving in a straight line and will continue to do so until they run into the side of the truck, which is turning. So the blocks are moving in a straight line, but they're actually hitting the side of the truck because the side of the truck is there in their way. The truck then approaches another intersection to make a turn. The truck can either take a left turn or a right turn as shown in the diagram. As soon as the truck approaches, makes a turn and continues in a new direction, all without changing speed. Yikes. So I've seen this guy drive this truck. It's scary. The centripetal force for the turn is provided by the force of static friction, which is determined by the relationship. Static friction is coefficient of friction times normal force. And if you were to explain why the force of static friction and not kinetic friction is exerted on the truck, even though the truck is in motion. Even though the truck is in motion at each instant, one part of the tire is at rest relative to the road so that it does not slide. If the wheels were skidding on the road, it would be kinetic friction, right? So the one part of the tire is stuck to the road at all times. Like each piece of tire keeps taking a turn, being the piece that's stuck to the road as it turns. Yeah, you'll notice I'm not writing this stuff out. All right, let's move on to part E. Part T. Yeah. We're going to have a part T. All right, in a few short sentences, explain what happens to the value of, that's the centripetal force, mv squared over r, is greater than the value of, if the value of centripetal force is greater than the value of static friction, all right, so if the, centripetal force is greater than the frictional force, that's what they're saying here. This is the friction, and this is centripetal. If the centripetal force is greater than the friction, then there's not enough friction to balance it, then the truck will slide off the road. All right, which turn, left or right, requires the truck to slow down more in order to make the turn safely? Centripetal force is equal to mv squared over r. If r is large, then v can be larger with the same friction force. If r is small, then v also has to be smaller with the same friction force. You will have to slow down more on the smaller radius turn, so you have to slow down more on the right turn, right? So if the radius is smaller, so this is all equal to this, right? Mu times the normal force. If the radius is smaller, then the velocity also has to be much smaller to keep the equal sign. If the radius is bigger, the velocity can be bigger. All right, where are we at on time? We're at 5.5 minutes. So we're going to stop and make a new video for part B.